Oh, jeez, I lost my fruit snack.
And we're live! Alright, so the warm-up for today is this. I gave you the answer. So calculators will do you no good.
But
How did you come up with it? Show me work. Show me how you would go about solving this problem. If you don't know how to do it, think about it. You'll know after we're done a couple of different methods.
Is this the warm-up?
This is the warm-up. How would you go about doing this? Find a clever way to solve this problem. Yes, you could just write this. Okay, this way does not count.
I'll scoot up some jeans. Be back more that way I can see over here.
This way does not count.
So the door's open.
Yes, it is.
Want me to close it?
Yes.
Okay. Wow, what a good person. What's the date? Oh, I need that.
24th all day.
Yesterday I said it was the 22nd. I went birthday last night. Wow, I'm so proud of you. It was the 22nd. We didn't do it yesterday.
Right.
Is today Thursday?
All day. That's one way of doing it. Find another way.
That's what I was trying to do.
Oh no. Oh no.
Really? That's the easy way. Yeah, I do think it's the easy way.
Easy if you have a piece of paper.
Well, I have a piece of paper.
And a lot of ways to make a mistake.
There's no other way. Exactly. He wants us to find the proof. He gave us the answer. What if my phone has a history? And I can see my proof there. Yeah?
Could you estimate it?
Yes.
How would you estimate it, Diana? 0.48 times 1,000. That's one way to do it. Could you correct for that estimation?
What am I doing?
You 0.5 times 921, right? And then correct for that estimation. How would you go about that? Think about it. Think about it. Song of the day is from the album Sleep Well Beast, the band The National. This album was released in 2017. The song is The System Only Dreams in Total Darkness.
Oh, wait. It's 8 times 8, 48.
What's 8 times 5?
Alright.
What's 8 times 3? 24.
Maybe I listen more than you think, and I can tell that somebody sold you. We said we'd never let anyone in. We said we'd only die of lonely secrets. The system only dreams in total darkness. Why are you hiding from me? We're in a different kind of thing now. All night you're talking to God. I thought that this would all work out after a while. Now you're saying that I'm asking for too much attention.
camera but for sound.
It looks like a camera.
So, how did you solve a problem like Maria?
I'm not done yet.
Do you need a little more time? I can give you a little more time. I'll stall. Hello.
When do you have lunch? Here next time. B. And I go to health and take notes. This is dumb.
Health is like the best.
Health is very Bailey,
Health is good with bug
Bailey,
guard.
health is
You guys don't have bug guard.
And how many snacks do you have?
a lot.
Free snacks for no
Sounds like a big meal.
Well, you used your extra time wisely.
Yeah.
So now, how do you solve a problem like Maria?
I got to 720.
Okay. First of all, look at this. If I didn't give you this. If we time something by 0.48, is that going to make the number smaller or bigger than 921? Smaller. So that's a, yep. So that's something to think about.
I was thinking we
If you
were-
wanted to estimate, you could estimate instead of 0.48, do 0.5, meaning half, right? Half of 921. It's going to be about 450 something, right? 460 and a half. You could also estimate 0.48 times 1,000. You get 48. 480, I should say. How did you solve a problem like Maria?
What did I do?
I don't know, Bailey.
I was trying to get 0.48 to equal 921.
Yeah, that's fun.
Wait. What? I'm so confused.
Yeah, you are.
Wait. I did 0.48 times 100.
Okay.
I got 48, and I did that times 10. I got 480.
So if we multiply 0.48 times 100, we get 48. Okay, great. Bailey,
Yeah.
we got 48. Now what?
I did that times 10.
Why?
I don't know. I got 480
Yes, you did. But why?
because 48 times 10 is 480.
Okay. So basically what she's doing is doing 0.48 times 1,000. Right? Because timesing by 10 and timesing by 100 is the same as timesing by 1,000. So we get is 480 either way. Exciting.
Yeah, and then
So that's an estimation. Now, what if I wanted to correct for that estimation? What would I do? I'd have to subtract, right?
yeah, 442.08.
0.08?
Yeah,
Why would I subtract that?
because that's the number.
I gave you that so you could check your answer.
Oh.
You don't need that. I know you don't. Well, we estimated 0.48 times 1,000, right? So we overshot by how much? $79. Hell yeah. All right. So we subtract 79 times 0.48. Because we did 79 times 0.48 too much, right? So how would we estimate this? 921 plus 79 is 1,000. We overestimated by 79 times, okay? So how do you solve a problem like Maria?
Why do you say that?
It's a quote from the movie. What do we do?
Calculator.
Nope. Well, isn't this the same thing as this? 79 times 0.5. Now we overestimated. How much did we overestimate this by? 0.02. So we have to subtract 79.02 times 0.02. Does that make sense? 480. What's half of 79? Well, what's half of 80? 40. So half of 79 is going to be 39 and a half. How do we figure out 0.02 of 79?
What was the question?
How do we figure out what this is? 0.02 of 79. Do you know 0.01 of 79?
Is it 1?
This bit right here is just 79 times 0.01. Whoops. Numbers are hard. Times 0.01 times 2. Isn't 0.01 times 2 the same thing as 0.02? So if I can figure out 79 times 0.01 and then double it, isn't that the same thing as doing 79 times 0.02? What's 79 times 0.01? What's 79 times 1? 79, move the decimal place over 2 because we're dividing by 100. We get 0.79, and now we're going to multiply that by 2, right? What's 70 times 2? 140. What's 9 times 2? So 158. Decimal point goes there. $480 minus 40, what's that? 440, but I subtracted too much, so add on a half. Now what? Now what? Quinn. Why are we adding 1.58? Why though? I thought we overestimated by 0.5, right? We overestimated with 0.5 when we really wanted 0.48. So shouldn't we subtract 0.02? Why? Because it wouldn't get us the right answer. Why? Yes, we should subtract the 0.02 and get what we got, and then subtract that. That negative would distribute, it makes it a plus, right? Whoops, 4. Enough.
Bless your heavenly soul.
Who's got another method? That was Bailey's. Yeah, tell me what you did.
Copy every
Well, I just think I just did it wrong. So like it probably could work.
That's okay. Tell me what you did.
I did 9.1 times 0.4, and then oh wait, I know what I did wrong.
Okay, tell me what you want to do.
And then I got that with the 8 over that, and then multiplied that by 8.
Multiply by 8.
Or 0.08.
Okay, so she got the answer here, and then multiplied by 0.08. Now, will this get us the right answer if we do it? Why not?
Because it's
0.08 times 0.4 is going to make that 0.4 smaller, right? So really what we're doing is 921 times a number that's smaller than 0.4. 921 times a number that's smaller than 0.4 won't be the same as this, right? Can't be. So what you want to do is this. Isn't 0.4 plus 0.08 the same thing as 0.48?
Wait,
And-
so you can do 9.1 times 0.4, and then add that answer to 9.1 times 0.4.
That's right. So how do we do 921 times 0.4? How about we do 921 times 0.1 and then multiply by 4? Is that valid? It is. How do we do 921 times 4? How you want to do that? How about we double it and double it again? Timesing by 4 is difficult because it means we have to carry bigger numbers, right, in our head. If we times by 2, what's the biggest number we'll have to carry if we times by 2? Think about it. If I times a number by 2, what's the biggest number I'd have to carry? A 1, right? If I do 2 times 9, I would carry a 1, right, for 18. But if I do 9 times 4, right, if I multiply by 4 right off the bat, then I could have to carry up to a 3, which is going to be harder to do in my head. So if I do it times 2 and then times 2 again, it'd be easier. So if I double it, I get 184.2. If I double that again, I get 4, 8, carry a 1. But again, carrying a 1's not too bad. I get this. How do I multiply something by 8?
Times 2.
Think about it. What's the biggest number I'll have to carry if I multiply by 8? Well, if I have to multiply 8 times 9, I might have to carry a 7, right? That's going to be god-awful thing. No, it's not. This is the same thing as this, which means multiply by 2 3 times, right? Double it, double it, double it. That's the same thing as timesing by 8. I can double in my head pretty easily. What's this doubled? It's that. What's this doubled again? Carry a 1 again. Carrying a 1's not too bad. Double it again. Carry a 1. Carry a 1. Now we're here. Assuming we didn't make any mistakes, we should get our right answer. 0.4 plus 0.68. That's 40 cents plus 68 cents. How much is that? 40 cents plus 68 cents. $1.08. So we have a 0.8 with a dollar. 8 and 3 makes 11. An extra dollar makes 12. Carry a 1. 6 and 7 plus 1. Well, that's the same thing as 7 and 7. Carry the 1. 11. Where'd we go wrong?
Oh no. What number are we trying to get?
442.08.
Wait. How did you get 1,142?
Yeah.
Thank you. What should we get?
Sounds like 442.
Well, we get a 3 here, actually. We're off by 100. Why are we off by 100?
Oh no.
Why are we off by 100?
Because we divided by 100.
It's a good guess.
You went
We
from
can just
921
subtract
to
100.
92.1.
That's how it
So
works.
you divided by 10.
Timesing by 0.1 gets us there. That's fine. Nope, it's okay. What about this one? Is that right? Are we right up to here?
That's a lot.
Are we right up to here?
Sure. No. Yes.
Good. Wait.
No.
What's wrong? What's wrong? 92 times 4. Estimate that in your head. Is it going to be bigger or greater than 184? A lot, right? Okay, so we multiply by 2 there. But we multiply by 2 again. Am I good? We doubled to get to here. What should be a 3? 184 doubled. It's going to get us 368, not 268. Good problem solving. Got another method? How about this?
I have a question about the one I did.
Yes.
It would just be distributed properly, right?
That's really what that is, yeah. It's creative distribution. How about this one?
I don't have any more room to write.
It's okay. You don't need to. It's about learning. 0.48 times 921. What'd you do, Hannah?
Nothing.
Or you want to say? What?
Nothing.
Oh,
I was just gonna say I haven't been writing anything. I've just been watching.
That's great. Isn't that great?
It's weird.
Yeah, but have you learned? Yeah, and that's the point. See, we judge learning, and we teach you that learning is associated with grades and writing stuff down and getting the right answer. And so what I do is I remove all of that, and we get to the real learning. Chaos. How about this? That's a 1. Why is that valid? Because really all it is this. Which is the same thing as 0.48 times 921, right? I just distributed. So it's her method, and instead of adding, I'm subtracting. I am doing this because I think 0.5 is easier to work with than 0.4. What's half of 921? Yeah? Well, what's half of 900? 450. What's half of 20? So now we're at 460. What's half of 1? How do I solve a problem like Maria? How about times it by 2 and then times it by 0.01? Isn't this the same? 0.01 times 2 is 0.02. What's 921 times 2? 1842. Good year. What's that times 0.01? What's 50 cents minus 42 cents? What's 460 minus 10? 460 minus 10, not 100. 460 minus 10. 450, now subtract 8. Now that's thinking. Now that is thinking. Put that away.
It's 11.
Yeah, you can turn it in.
Wait, spell
It's
it.
third.
It was that like
Yeah.
Wait, Marissa, this is not. This is wait. That was not yours. Yeah.
Once again, we did not write Hannah's name on the board, Bailey's name on the board, or Nellie's name on the board.
I'm sorry. Can Jamie be a good
Wait, where's his name at?
Can her nephew?
No.
Whose nephew?
Hannah. Yes.
Who's Hannah's nephew?
That is funny.
No! Why do you have that?
Guess what level of Candy Crush I'm on?
That's the only one.
1,159.
1,186.
Oh.
I'm on 1,000.
That's the right question. Okay, go ahead. I got something for you.
I didn't play for a long time because I was stuck on a level. And then I passed it. How are you so?
You just dedicate your life to Candy Crush? Yeah, that's what I'm saying. Let me just. What? I do. Guess what level I'm on Helix Jump?
That'll make everything.
Thank you. What's it called? Helix.
Put it away, you dingus.
Abuse.
What's Helix Jump?
None of these if you do it to both
I was
sides.
just sharing my level.
Anyways. I'm on.
We talked about it. Robert says as long as you do it to both sides, it's fine.
Actually,
I'm on level 1,120.
Ellie.
How do you know? I just have to play it. I just haven't deleted it because I'm so far. This is my favorite game.
games hit different.
We've been doing this the last couple of days. What's wrong with you guys?
This is an algebra.
I know.
Yeah, that's the one thing.
I know. It's the only thing you ever remember, and you don't know what it means.
It's y doing this.
All right, so
Too much.
formulas are BS. Okay, we're actually going to learn what these mean today. Okay, so shut up. It says write the standard form. It says write the standard form for an equation. Now here's the deal. Lowercase SF standard form is just saying, hey, it's the thing that we see the most often. Okay? Capital SF standard form is an official name for something. Okay? Standard form is not this with a capital S, capital F. Okay? This is called slope intercept form. They call it that because it gives you the slope and the intercept of your equation. M is slope. We've talked about this. The reason for that, I assume, and you know what that does to us, it makes it add and, is that French people, like René Descartes, the Frenchman, right, the guy who invented the Cartesian coordinate plane, named after him, he used M for slope because I believe the word for slope in French starts with an M. We use B for y-intercept because A is the x-intercept. You just never ever see it. And x and y are already taken. X and y pertain to the coordinates of the Cartesian coordinate plane. So M is the slope, right? We're talking about the angle, right? And B is the y-intercept. And we can't call it y for the y-intercept because y and x are already taken. If you see an A, that's the x-intercept, yes. But we don't see that in this form. So they call it the slope intercept form because it gives you the slope and the intercept. I know. I know. Graph the following equations of a line. List the slope and the y-intercept. So, number one, they give us the equation. Here's the equation. What form is that in? Slope intercept. There's a million ways to write the equation of a line. Not a million, but there's a lot, okay? That form right there is the one that you're going to see most commonly, although it is not called standard form. It is called slope intercept because it gives you the slope and the intercept. Our slope is M, and our intercept is the y-intercept, B. Landry, what is our slope for this one? We're on number 1. 2. Also known as 2 over 1. Also known as what? Rise over run, that's true. But also, what's another equivalent numerical representation for 2 over 1? Sure. Negative 1/2 would not work. That's a different number. True.
4 divided by 2.
Why is this important? Because we can either go up 2 to the right one, or we can go down 2 to the left one. They're the same dumb crap. So, what's our y-intercept? The b value? 1. Which means we're going to hit the y-axis at 1. Why is this useful? Well, what we need is we need 2 points to make a line, right? So the y-intercept gives us a free point. There's nothing special about the y-intercept. Okay? It's just we get a free point. You should take the free points when you get them, right? So now we're going to use this point to find another point using slope. Because whenever you pick a point on your line and you use slope, you'll find another point on your line. So I know my slope is up 2 over 1. So if I go up 2 over 1 from that point, I will have found another point on my line. And we only need 2 points to make a line. If I started from here, I could go up 2 over 1 as well and find another point. I could keep doing this. I could also have gone down 2, left 1, and it would have gotten me the same thing. Do we see how that's still going to be on the same line? Wonderful. So now we connect those dots with a protractor that you can pick up at Farm and Fleet.
Or a flexi ruler.
Flexi rulers are completely useless.
Well,
There is no point to those.
fine.
Use a protractor.
I don't want a protractor.
Good things.
Thanks, Diana. So, now, the last part of the directions. Be sure to plot the y-intercept first, blah, blah, blah. Then write an equation of a line that would be parallel to that line and through the given point. So we need another line that's parallel to this line. And it goes through the given point. What's the given point? This is the given point. So we need a line that goes through 1, 1. Here's 1, 1. Sorry, they're so close together. And we need a line that's parallel to that. Well, if it's parallel, they're going to have the same what? Slope. So if this one's up 2 over 1, this one should be up 2 over 1. And if we do that, it'll be parallel. Same thing with down 2, left 1. Now it says it wants the equation of that line. So we've drawn it. What would the equation be? Well, the blue, or I'm sorry, the purple line is y equals 2x plus 1. In slope-intercept form, what would be the equation of our blue line? Well, first of all, they have the same slope, right? So it's going to be 2x.
We just have different y coordinates.
What's the y-intercept for our blue line? -1 is where it crosses. And we can tell that because not just because we drew a good line, but because we can go from this point down 2 over 1 and it hits exactly on the y-axis. There's where it is, at -1. You feel it now, Mr. Krabs? Next one. Using more ink, we could rewrite this as y equals 1x plus 0. It's the same dumb crap. Now, if we had a 0 in front of the x, that would be 0 times x. And 0 times anything is what? 0. So there isn't a 0 in front of there. Because if it was, everything would be gone and we get the line y equals 0, which we have seen before, but you just don't remember. We're going to see it soon. Ellie, what would you like to say? Yes, I can. Bailey, what is our slope?
1.
Also known as?
-1 over -1.
Very creative. And also known as?
1 over 1.
Cool. Also 2 over 2 and 3 over 3 and et cetera, right? We're going to think about what that means. Y-intercept, 0. So starting from the origin, we can use our slope to construct the line. I go up 1 over 1. I can also go down 1, back 1, right? Either way works. And then I construct my line. So far, whether you remembered it or not, all of this is actually review. Now we're going to think. This equation is y equals x. What does it mean when we say y equals x? I'll give you a hint. X and y are the coordinates. What does it mean for y to equal x? They're the same. They are the same coordinates. So examples of coordinates that would exist on this line. Hannah, give me an integer.
2.
If x is 2, this says that y is going to be whatever x is, right? So 2, 2 would show up on this line. Does it? It does. Give me another integer. Mark.
3.
So 3, 3 would show up in this line. Pi comma pi would show up on this line. Negative root 2 would show up on this line.
This is way too complex.
No, it's not. I'm just saying that every real number will show up on this line, and it will have a pair, a coordinate pair. And the relationship between those two numbers is that they're the same thing. That's what this means. Whatever x is, y is. So when you go to graph this, if I see y equals x, I don't even need to think slope or y-intercept. I know 0, 0 is going to be there. I know 5, 5 is going to be there. Draw a line. All right? Think about what it means. This is a relationship. Y is x. They're the same. Go back up to the number 1 for a second. What does it mean for y to equal 2x minus 1? What does that mean? Pause. We'll go back later. Go back to number 2. Let's find a line that's parallel to this that goes to the point 2, 3. 2, 3 is here. Sorry, it's so close together again. Same slope, because it needs to be parallel, right? Our slope is up 1 over 1. And down 1, back 1. Et cetera, et cetera. The purple line is y equals x. That's the relationship. The blue line has a similar relationship. Y is going to be the same thing as x, except everything's moved up 1, right? That's what happened to the line. Now, what variable deals with moving things up or down? Which variable deals with the up and down? Is it x? Or is it y? Which variable deals with the up and down? I ask the questions! Y. Thank you very much. So, y. So if x is the same thing as y, but everything's shifted up 1, really what we have here is x is the same thing as y, but everything's shifted up 1. So whatever x is, add 1 to it, that's what y will be, right? Y will be 1 bigger than x. Y is 1 bigger than x. Y equals x plus 1. So examples of coordinates that would be on that, Nellie, give me an integer. 3. Which means we would expect 4 to show up, right? 3, 4. We'd also expect 5, 6. Negative 1, 0. Do you see how if I just know what that is, I can graph it super fast? Right? Pick a value for x, add 1 to it. There's your coordinate. Bam, draw it. You could also do, there's the y-intercept. Let's use slope, right? What does it mean for number 1? Y equals 2x minus 1. What's the relationship between y and x? If x is 7, what would y be? Well, 2 times 7, which is minus 1, which is 13. So the relationship is whatever x is, double it and subtract 1. So if you need 2 points to graph it, pick 2 numbers. How about 0? If I plug in 0, it's 2 times 0 minus 1, which is negative 1. So that makes sense, right? You double whatever x is and you subtract 1. Those 2 points are going to show up. Draw a line. That's all it means. Any 2 numbers that are separated by doubling and subtracting 1 are going to show up on this line. That's what that means. Turn the page. 3, 4, and 5 I think you can handle. Turn the page again. Look at 6. What does it mean? Y is 0. Does it say anything about x? No, so x can literally be anything. But y is always going to be 0. So example of points that are going to show up on this line are any point where y is 0. So let's make up some points where y is 0.
I think it's a flat line.
Marissa, give me an integer. So 4, 0 is going to show up. Ellie, give me an integer. 2, 0 will show up. Bailey.
74.
74, 0 is going to show up. So we'll negative 74 is 0. Any coordinate where y is 0 will show up. So let's find where all the coordinates are y equals 0. Well, 2 zeros here. 4 zeros here. Whoops. Yep, no, we're right. 4 zeros there. 6, 0, 0, 0, negative 2, 0. All the points where y is 0 will show up. So what kind of line is this going to be? A horizontal line. And that's the line y equals 0. Y is always 0, is what that means. Now, if we want to go through 5, 4, here's 5, 4. 1, 2, 3, 4. And we want a line that's parallel to that. It's going to be horizontal as well, right? What is the equation of the blue line? It's where y is always what? 4. Every point on this line has a 4 for y, right? Here's 5, 4. Here's 6, 4. Here's 7, 4. Here's 0, 4. Here's negative 1, 4. It's where y is always 4. Do we need to know what x is? No, because there's no relationship between x and y. X does whatever it wants. Y is always constant. It's always 4. Y does not depend on X. They're both independent. What's our slope for this? Think about it. Think about it. What would our slope be for these lines? What does slope mean? Yeah. It's going to be 0 because our rise is 0, and we run as much as we want. 0 divided by anything is 0. Also, slope is the steepness, right? Flat line, horizontal, 0 steepness. Another way to write this equation up here is y equals 0x plus 0. Isn't 0x plus 0 the same thing as 0? Y-intercept is 0 as well for the black one. Think about what 7 and 8 mean. Look at 7. What does that mean? X equals 0. X is always what? X will always be 0. Does it say anything about y? No. So y can be anything. X is always going to be 0. Here's x always being 0. Let's list some coordinates where x is always 0. Mark, give me a coordinate where x is always 0. 0, 5. Landry, give me a coordinate where x is always 0. 0, 8. Calvin, give me a coordinate where x is always 0. 0, what? 0, 12. We'll make it negative just for fun. So all those coordinates will show up on this line. So here's 0, 5. 1, 2, 3, 4, 5. Here's 0, 8. Here's 0, negative 12. 2, 4, 6, 8, 10, 12. What kind of line are they going to form? Vertical. That's the line y, or sorry, not y equals 0, but x equals 0. It's where x is always 0, y can be whatever it wants. What's our slope here? We go up as much as we want, right? And we go over nothing. What happens when we divide by 0? We aren't allowed to. We call that undefined. If we were to give that a definition, it would break math, so we have to call it undefined. Undefined slope is vertical slope. We go up infinitely, and we never go over. Dividing by 0 is not allowed. What's our y-intercept for this line? 0, or 1, or 2, or 3, or 4. It hits it all over, doesn't it? So what do you do with that? Does it have a y-intercept? Does it have infinitely many y-intercepts? We want a line that goes through negative 3, negative 2, and is parallel to that. Here's negative 3, negative 2. If it's parallel, it has the same slope, which means it's also going to be what? Vertical. What's the equation of that line? All of the points on there have something in common. What do they all have in common? X is going to be always what? Negative 3. Negative 3 comma 0, negative 3 comma 1, negative 3 comma 10. They're all going to be on there. 1 through 8 are your homework. See you tomorrow.
Did we already do half of those?
Yes.
Good, because I have like 20 assignments tonight and we have volleyball games. So.
Exciting. My homework, I don't think, has ever been over 15 questions. And most of the time, if it's 15 questions, we do 7 of them in class.
Spanish, bio, English, geometry.
I shall return.
I need to pass for automatic.
During now?
Yes. We have the same scenario, so.
Gotcha.
Thank you, sir.
Shut up, Brandon, you're dumb.
Zach, did you know that? He's got a bald spot.
I've been the one that pointed it out.
Oh, did you?
Where's Mr. Mack? Mr. Mack.
Is it your? Be quiet about it. Are you with this class?
Fair enough. Sharing is caring. So, Brandon, did they have any homework yesterday?
Nope.
Did not. What about this?
Show Mr. Matt.
I finished it.
Awesome.
Mr. Max, I got a warm up for us.
Yeah, you do?
Only geniuses can solve.
Hey, and yesterday I didn't count because I had to work. So
Fair enough.
You'd have to look it up to like get all the rules, but you got unlocked a lot.
oh,
This is dope. I played a game when I was younger called Dr. Quandary. It was on the computer. It was like when computers were like still like awful for video gaming. So all they had was like educational stuff. And there was a problem like this where you had to get a kid out of the stocks. This is good.
Want to get my point? Oh, how the water get on
Yeah, I would just wash my hands. Sorry, I have a Band-Aid.
can I go get a drink real quick?
I'll take a look at it. Eads, write your name on it.
I have the answer.
Yeah?
Chromebook.
Okay. You can write the answer down too. We're not going to do that today, but I'll do it at some other point.
I forgot, to be honest with you.
No. Go write it down.
I think it was like 058 or something.
Can I go tell Primo something real quick?
Yeah, you might.
That was rude.
Alrighty. Here's your warm-up for today.
Ow, get back.
Yeah. Ouchie, ouchie.
Stop.
You stop. Keep it up, I'm gonna eat Jeff.
Do it.
We're gonna barbecue it.
Do it.
Some sweet baby
Appreciate
He
it.
might kill you. Jeff's a savage.
He's a goat.
Your warm-up is, how do you solve a problem like Maria? Find multiple ways to do it. I'll show you two ways. Or actually, one way. No, I'll show you two. Come on in. Have a seat.
Hey, it's the guys.
First way is use a calculator.
I don't have a third.
Did you say calculator?
Well, I'm trying to eliminate different ways you can do it. I don't want them to do it with a calculator, so I'm saying I did it with a calculator. Haha.
You gonna share?
Another way to do it is this.
Wait, so what's the warm-up? That?
The warm-up is, how would you go about solving this? And by you, I mean, how else could you solve this? Think about it. Think about it. Could you estimate it? How would you estimate it, Eads? Instead of doing 0.48 times 921, what would you do? 0.5, maybe? Maybe 0.5 times 900?
I can't find my warm-up sheet.
Could you do times 900 times 20 times 1?
You have to find out. You can check yourself because there's the answer. Right? That's why I gave it to you. So we could also estimate 0.48 times 1,000. We could really estimate and do 0.5 times 1,000, right? It's about 500-ish, right? Could you correct for that estimation? So if I did 0.5 times 921, that's going to give me a number that's too big, right? Because it's half of 921, and I only want 0.48 of 921. How could I correct for that? Think about it. Think about it. 0.45 times 921. Maybe that'd be easier to do in your head. I don't know, right? I think 0.5 is pretty doable. Think about it. How would you go about it? I've already done it this way, and I've already done it using a calculator. How would you do it? Check your work against the answer, but the answer is not the important part. It's how you do it. Again, it's not what you do in life, it's who you do it with. Work together. Maddie, where's Maddie?
Not here.
In Indiana. She having a good time, or is it like not a good time?
It's a good time.
Good for her.
She ain't gonna fight us.
Take me with you next time, Maddie.
Going to her boyfriend's brace.
Going to her boyfriend's bris. What?
Race.
Oh, race.
Man, I could have won.
It's like that'd be awkward.
What'd you say?
Bris.
Do you mind this bubbly buffoon?
Grab shoes.
Is that a cereal bar or something?
Song of the day by The National.
The National.
The National. Released in 2017, the album is Sleep Well Beast. The song is The System Only Dreams in Total Darkness.
Ooh.